Ever wondered if you could learn to use MXNet in less than a week? Well, the answer is a resounding yes. So, buckle up as we delve into the first 6 steps you can follow to harness the power of MXNet functionalities swiftly and effortlessly. First things first, we need to install MXNet and the necessary components. MXNet is an open-source deep learning framework that allows us to build, train, and deploy neural networks. To install MXNet, you need Python and pip installed on your computer. Once that's ready, open a terminal and type in pip install MXNet. In a few minutes, MXNet will be installed and ready for use. Once installation is complete, our next step is to learn about the NDArray data structure in MXNet. An NDArray, or n-dimensional array, is a multi-dimensional container of items of the same type and size. It's similar to a NumPy array, but it comes with powerful functionality, like executing operations in parallel and automatic differentiation. Understanding how NDArrays work is vital as they form the backbone of data handling in MXNet. With our knowledge of NDArrays, we're ready to build a simple neural network using MXNet. A neural network is a series of algorithms that endeavors to identify underlying relationships in a set of data. In MXNet, we start by defining the architecture of the neural network. This involves specifying the number of input, hidden, and output layers, and the number of neurons in each layer. Next, it's time to train our model on a sample dataset. This involves feeding the neural network with training data, which it uses to adjust its weights and biases to better predict the output. MXNet provides a variety of optimization algorithms for training, such as stochastic gradient descent and Adam optimizer. Once our model is trained, it's important to evaluate its performance and identify areas for improvement. This can be done by using a separate validation dataset and calculating the model's accuracy, precision, and recall. If the model's performance is not satisfactory, you can tweak the architecture, change the optimization algorithm, or increase the number of training epochs. Finally, we're ready to deploy the trained model for inference on new data. This involves using the model to predict the output for new, unseen data. In MXNet, this can be done using the model's predict function. In conclusion, mastering MXNet is a journey that begins with installing the framework, understanding the NDArray data structure, building and training a simple neural network, evaluating the performance, and finally deploying the model. As you progress through these steps, you'll find that MXNet's flexibility and efficiency make it a powerful tool for deep learning. Just remember, like any skill, proficiency comes with practice. So get started, experiment, learn, and most importantly, have fun with MXNet.